we've looked at the three energy systems, and now it's time to really unpack this idea of interplay, the notion that the energy systems work together. No one energy system works by itself. They all contribute various amounts at various times according to intensity and duration. This graph on the title page is one of a number that you'll see in this slideshow. So there's no one universal interplay graph, but this one shows somebody working for over 6 minutes, and certainly by the contributions, they've worked incredibly hard in the first 30 to 60 seconds before they have tailored off their intensity. Key knowledge here talks about interplay. It's been in each of the other ones. We've talked briefly about how the anaerobic systems work as a unit, if you like. Now it's time to look at all three. Central question then, not surprisingly, how do the three energy systems work together to restore ATP for movement?
The guiding questions start with asking you to define interplay and then get you to consider factors that affect interplay. You'll then unpack a number of graphs, and then ultimately I'll suggest a template which should get you through a extended answer question. So I'm calling it a template to help plan your responses, and there's a couple of practice attempts there with paragraph length extended answer tasks.
Which might be the easiest one for you to remember. Three energy systems working together to produce the energy required for the activity undertaken. You don't have to remember that word for word. That's fine. In terms of factors that affect interplay, the two obvious go-tos are intensity and duration, but there are other factors. So knowing what you know about the chemical pathways, the food and chemical fuels, the intensity, rate, peak power, duration, fatiguing byproducts, all those characteristics of the energy systems, you should hopefully be able to work through, other than intensity and duration, and this has been an exam question, factors that affect interplay. And here are some answers from that question. You were able to put intensity and duration for the first two, but the third one was pretty difficult for people. If you work through bullet points 3 till the end and start to see why that might affect with interplay, you'll be doing really well. Ask me when unsure. For example, how does hydration affect on interplay?
This is my attempt to unpack what happens within the body for you to then join the dots, if you like, to make the connection with what happens to energy system use or interplay. So I've got answers for different types of muscular contraction and training status. I'm not 100% sure how nutritional status can impact interplay. I do understand it will impact the chemical fuels the aerobic system uses. Equally, I can talk about heat, altitude, and hydration. But task dependent is another term I'm not particularly clear with. But I suppose what I want you to do is to extend my little half sentence to give me an indication of, does that mean we use the aerobic systems more or less, or the anaerobic systems more or less?
Put simply, interplay explains that there's never only one energy system working exclusively at any one time. It might be the case that an energy system is not doing a hell of a lot at a point in time, but the other two will be doing something. They overlap rather than saying this one turns on, then turns off, then this one turns on, this turns off. Then it doesn't happen like that. They are, at least two of them are on all the time, and they work collectively and together. At any one point in time, though, you should be able to identify a dominant energy system. The image on the right-hand side actually looks at the fuels contributing to energy systems, but you hopefully get the idea that there is a combination of energy systems working there by use of the food and chemical fuels that are identified there. A couple of things for you to put in your little fact bank. In a continuous event, once the aerobic system is dominant, it stays dominant. So a sprint finish at the end of the marathon would still see the aerobic energy system dominant. You would just draw increasingly on anaerobic pathways. The latest time point the aerobic system can be dominant is 75 seconds. It can be dominant much earlier. And in fact, in a marathon, you wouldn't sprint in the first minute at 75 seconds. So the aerobic system would be dominant, I would say, at about 30 seconds. Okay. In terms of any team sport, once you've got a break in play, things start to change all over again. After 3 minutes of a passive rest, you can actually totally restore your CP system such that that could be dominant at the opening play following a 3-minute break. So continuous versus intermittent events really dramatically change how you discuss interplay. Answering interplay questions, I would say if there's no definition provided in the question, I would start off with a definition. It would also get me just into the mood, like an introductory sentence. Interplay is. Do that. If it's in the question, don't waste your time. You've really got to talk about each of the three energy systems. Even if one is negligible, you need to talk about all three or you've missed something out. And use the jargon, rate and intensity, yield and duration. Alrighty? Make the most of any data you've got, if it's time points or heart rates. And talk about increasing and decreasing contribution. It might be difficult to talk about dominant energy system throughout the event, but at some time point you really should mention which is the dominant energy system. It's probably easiest to do as the overall dominant energy system upon completion of the event. And in the interim, so like at this point, and this point, and this point, an energy system will increase or decrease according to intensity and duration. So in looking at this interplay graph, the same one as the title page for the slideshow, let's just have a look at a particular point in time versus the dominant overall energy system. If we looked at, for example, I would say 20 seconds in, you trace that line up, I would say the anaerobic glycolysis system is contributing approximately 60% of our total ATP energy needs. So that would be dominant at the 20-second mark. However, if you look at the right-hand side of the graph and at 6 minutes and a bit, clearly the energy system that's contributed the most ATP would be the aerobic energy system. So the overall dominant energy system would be the aerobic, but at the 20-second time point, as an example, the anaerobic glycolysis system would be dominant. Here's an example of a slightly ambiguous graph insofar as there's not really not enough data to tell exactly where the time points are for these ebbs and flows on the three energy systems, nor are the three energy systems even identified. But hopefully you would suggest that the blue represents the ATP CP system, the red the anaerobic glycolysis, and the green the aerobic. The difference for this graph compared to others is the time points look a little bit strange. So have a look at that and tell me what you think. Where do you think, at what time point is the aerobic energy system dominant? It's not the easiest graph to read. Going old school now, black and white. And I don't want you to get sick of interplay graphs, but you have to get familiar with interpreting data. And all the axes might have slightly different names. All the energy systems might have slightly different names. In this case, we've got mitochondrial respiration. That's a pretty unusual name for the oxygen system, but that's obviously what it means. So playing with that, pulling it apart, what does this mean? How can you interpret it? Those kinds of things. Here's a very well-known table, and it's a table that gives us our data for the range, or the last range, for anaerobic glycolysis being dominant before the aerobic energy system becomes dominant. Now this graph really it breaks down aerobic and anaerobic. It doesn't split ATP, CP and anaerobic, but you can see that at 75 seconds there's almost 50-50 contribution from aerobic and anaerobic, and in fact it's the first time point when aerobic as a 51% contributor becomes dominant. So that's the last time point. The people doing this were working at maximal exercise. In most cases, it's very hard to do anything maximally up to 75 seconds. So in most cases, the aerobic energy system will be dominant much earlier.